Hi, can you hear me? Wait, just checking the internet speed. Am I lagging? Huh? Not really? Okay. Hang on, Okay. I think this was your first question, I believe. Yeah, I think from the whole list of it, right? Okay. Can. Hang on, let me just get some things out of the way first. Right. There's no working here though. What's going on? There's no working here. Hello? Yeah, sorry. There's no working here. Like there was no working done. What happened? Okay. So it says first hole has a volume of 20 and the second hole is half the volume of the first hole. So it's a bit silly. Um, so basically, I mean, the second hole is just 10, right? So basically it's just 10, right? 10 cm cube, right? Okay. So what happens is that you have a material, right, that had 100, 100 cm cube. It was 100 cm cube at first, right? You can see there's 100 cm cube here, right? And then you drill one hole, right? And then you drill another hole, right? And basically, because of the two holes that you drew into, right, the total volume is now minus 20 and then minus 10. So the new volume is 70 cm cube, right? Correct? Yeah. But don't forget, when you drill holes, right, you lose material. So you need to figure out how much material you have lost. You have to find your new mass. This is your new volume, right? New volume of the thing. Right? Oh, okay. No, 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 no. Um, geez. No, no, this is not a fair question. This is not a fair question. Ah, okay, wait, I give you another I give you another idea first. Wait, hang on, I give you another idea first. Wait, let me just get rid of all these pictures first. Wait, shit, sorry, bit lag. Wait, sorry, hang on. Sorry, so annoying. Okay. Right, I give you another scenario first. Wait, you still there? Okay. What's the density of like iron, for example? Let's think about density of iron. Like a piece of iron. Like what's the density of iron? Is it denser than water? Yeah, obviously it is, right? So if you throw a piece of iron into a tank, okay, okay, a water tank, it will sink, right? But you see, right, cargo ships are made of iron. Like the entire cargo ship is made of steel, right? So why is it that the ship doesn't sink? No, I mean it's due. It's basically due to density. The moment that you know something is like floating, right? The moment you know that something is floating on water means that the entire object is less dense than water. You understand? Right? But then it's made of iron. You see, it's made of steel. So how can a ship be made of steel and still float? That's I think that's the that's the big question. Because when you calculate the density, right? When you want to calculate the density of a cargo ship, for example, right? You take the entire mass, okay, take the entire mass, but you divide it by the gigantic volume, like the volume of the shape. You know what I mean? Yo, yeah. So that's the thing, right? You're you yeah. So this thing here is not very fair because this question. Where do you get this question from? Oh gosh, it's such a bad question. I mean, it's a very badly worded question. You get what I'm saying? Yeah, it's a very badly worded question. So I can imagine how some people like will be very confused by this. And I mean, how would I know what they want, right? So what they're saying is that they take this object, right? They take this object. They take this object, okay, and then they drill two holes into it like that, okay. But the overall volume still stays at 100 cm cube. You know what I'm saying? No, wait. Ah, what? This was your exam question? What a stupid question. Ah, no, I'm talking about like I thought this was your past year paper. Yeah, as in like, I thought no, I thought it was your paper itself, like the one that you did last week. It's not, right? Oh, it's such an annoying question. At first, I thought they were talking about ship, right? I thought they were like doing it like you drill a hole, so the overall volume is still 100 cm cube. And then I realized that no, it's not. They drill a hole through, right? They probably drill a hole straight through to the bottom. Oh gosh, you understand what I'm saying? They drill a hole straight through all the way to the bottom like this. And then they ask you what's the density of the final object, right? Okay, it's a very unfair question because what they mean is that they want the final density of the material. Do you understand that even if you drill holes through, the density is still the same? You know what I'm saying? It's like if you have a small piece of iron versus a big piece of iron, but you don't shape it into some weird shape like a ship, right? Then the density is the same. But you see, right, like I find it very annoying when teachers they're not clear on the question. So this unfortunately this is an example, right? So what they're saying is that even if you take let's say for example you take a big piece of metal, right, and you cut out a small chip of it, Like you chop, you cut, you saw off a little piece of it, right? And they come out. Then I ask you like, oh, okay, so what's the density of this small piece of metal that you chipped from the big piece of metal? The density is the same. Yeah. So this one here, even if you drill a hole through, what they're saying is that density is the same. At first, I thought it was like that, so I was ready to tell you it's four. Then I was like thinking, oh, did they mean that you drill a hole so that it can float or something like that? Then I realized, huh? No, as in like the mass per unit volume is still the same. Like the amount of mass that you have, because you drill a hole, right? You drill a hole through, you lose mass, right? Some mass is gone, correct? So if there's missing mass but there's less volume, so mass per unit volume will still end up being the same. Okay, yeah, yeah. This is a very annoying question. Sorry, I'm making a mess out of it. Sorry. Okay. Um, let's try this one then. Yeah, you understand this one already? Yeah, mine. Okay. This one I understand. Yeah. What's wrong with this one? Yeah, lah, correct lah. Because there's air inside, right? There's trapped air, right? Yeah. So this one. But do you understand that? Like, it means like a normal barometer should not have any trapped air at the top. Yeah. Like this is not a typical mercury barometer. There's something wrong with it. It's not typical. You know what I mean? It's a faulty mercury barometer. Faulty. If you have gas trapped inside here, it's a faulty mercury barometer. Yeah. Huh? Pack things. You want to pack things? Where do you want to pack it? Oh. No. You can't walk across the this, so you pass it to me, please. What's the next one? Is it this one? Okay. Good night. Good night, right? Right. Okay. Say good night. No. Wait. Say good night. Okay. Okay. Go. Yeah lah. Sorry. Let me just paste it here. Good night. Good night. Good night, Ollie. Good night. This is the first one. I got another one at 9 o'clock. I end 10:30. Yeah. Isn't it just A? Isn't it just A? Yeah. Yeah, it's just A lah. But do you know why? I mean, yeah, it is laterally inverted, but how come it looks like it's you know what happens is that it looks like it's also inverted. I mean, laterally inverted, yes, right? But it looks like this is a upside, this is a right side up P, whereas this one is a like a upside down P. So it looks like that, but it's just that the way they put the paper, you know what I mean? Yeah. Like okay, it's because I'm just thinking about how I can explain it better rather than just tell you that oh yeah, it's no the answer is just A lah, you know. Um, you got to think about you got to think about Wait, like kind of like the like okay, so this is the mirror, right? Then you got to think about the points of the object is at the same distance from the same points on the mirror image. Like like for example, the distance between like here, right, to this point here and this point here is the same distance to the mirror, right? Yeah, the same distance. So then the curved edge here, the curved edge here, they have the same distance, you know, to the mirror, like that distance there and then that distance there, right? Right? And then this one here, the ends of the P, like they have the same distance, like to the object and from the mirror to the image, right? So they have the same distance to the image like that. So I mean, yeah, that's why A is the answer lah, right? I mean, if you look at B, B is wrong because like you see how it goes across like that. It needs to be perpendicularly across the mirror, not like at a slanted angle like that, right? You get it? Then you see like for example C is wrong because you see how the base to the mirror is like here, right? Right? The base to the mirror is like here, but then this base to the mirror is like much further away, so it's like that's not quite right, right? Yeah. Then same thing lah for D as well. Like this base is like to the mirror here. How come that base is like here? It needs to be perpendicularly across, not diagonally across like that. You know? Yeah. So anyway, A is the answer. Like if you had no choice to put, like what would you have put? Hmm. Okay. Just take note of that lah. Okay. This one here. Oh, this unfortunately this question is not really in syllabus anymore. Yeah. This particular question is not really in syllabus anymore. But I can show it to you lah anyway. I got half a suspicion I need to teach this. Even though it's not in the syllabus anymore, I still got feeling like some teachers will still test it. So I might teach it just for the sake of like helping you understand how to do some of these questions because sometimes teachers will still test it because they would either they're not aware that it's completely not in syllabus anymore or you know but quick one okay, right, so what we have here is let's say I want you to imagine that there is a gas syringe, right? Gas syringe. What happens when you push the piston in? What happens to the volume? The volume will decrease, right? Okay. What will happen to the pressure? So what happens is that there's a relationship which is not taught to you because it was just not in the syllabus now, right? There's this relationship saying that P is inversely proportional to V. Yeah, I know that's the problem. It's not actually in syllabus. I don't think it's in syllabus anymore. Because I compared the syllabus before. I see the old syllabus, the last year's O levels and this year's O levels. That part on the relationship between pressure and volume and temperature, that part has been taken out. Mm-hmm. But it's okay. I can teach it, right? I know it's not in syllabus, but then like I say again, some teachers still forget that it's still in. They may accidentally test you, and therefore you like, do we want to just say that, oh, this question is no longer in syllabus, then how? Or do we just want to try to get it? Because I do believe that there's actually some benefit of getting it. Yeah. Okay. Right. So so P is inversely proportional to V. Okay. um what that means is that when volume increases, pressure decreases. When volume decreases, pressure increases. Make sense? Okay. How would you draw a P versus V graph then? If it's inversely proportional, like math, like how does a graph like this look like? It is a curve lah, right? You will see a graph that looks like this, right? Because that's the y is proportional to 1 over x graph, right? Correct. So that's the graph, right? Yeah. So then but the thing is that you're not given any option where it's p versus v. They gave you options all like p is like 1 over v, like the x-axis is 1 over v. But do you understand that there is another way of reading this relationship, right? Do you understand that the I can read it as pressure is proportional to 1 over v, like it's directly proportional to 1 over v, which means that if you ask me to plot pressure versus 1 over v, I will get a straight line that passes through origin. And that's why A is the answer, you see? But why is it like like how is like when is this important? Actually, this is quite important, right? Especially when it comes down to like let's say for example they make you plot, right, a graph P and V. You understand? So if you plot P and V, you're gonna get a curve, like all the time. You're always gonna get a curve, right? And in physics, right, we don't exactly quite like curves, right? The question is, how do we draw a straight line graph? So then you have to plot P against 1 over V. That means you have to come up with a column of data that is 1 over V. Let's say like, oh, P is like 1,000 pascals, for example, and V is like maybe 20 cm squared, right? Then 1 over V will be 1 over 20. That means you have to come up with all the data of 1 over 20. Then you plot 1,000 against the 1 over 20, and then you plot. You should get a straight line. You get it? Yeah. This is how it should work lah. Hey, give me a while. Hang on. Let me just try to do something first. Wait, need to get something done. Sorry about that. Hang on, Oh, sorry, because I'm actually teaching you from home and it's in a makeshift. I'm still haven't finished unpacking my room yet. It's like super messy. Yeah, lah. Yeah. It's like my makeshift office right now. Check balls. You know. Okay. Anyway. Okay. So there you go. That's the um. That's the graph there, right? So it has to be A lah. A is the answer. Okay. But yeah. So what you're doing is you're trying to change the volume, and we want to see how the pressure changes. I mean, yeah, I probably will actually just take half a lesson to teach the rest of this. I'm quite annoyed by it because I suspect some teachers still doesn't understand that it's off yet. So essentially that for gases, right? For gases, there are three laws. Okay. Um, no, not half a lesson. I'm just going to do a very quick one here. So there's pressure versus temperature, there's volume versus temperature, and then there is pressure versus volume. Okay. So pressure versus temperature, they're supposed to be linear. right? Directly proportional, right? So P is directly proportional to T. Volume versus temperature is also supposed to be directly proportional, so volume versus temperature. But P versus V is inversely proportional. But if you were to plot it as P, right, 1 over V, like this, then it'll be directly proportional. Like that. You understand? Yeah. And anytime you get a temperature, right? Anytime you get a temperature, that's in kelvins. Yeah, that's in kelvins. Okay, yeah. Yeah. Okay, that's in kelvins. So yeah, what's the next question? This one? How come you seem to be doing all the density questions? Oh, okay. When will the results come out? Okay, it's fine. Don't worry about it lah. You if you just keep on practicing like that, it's fine. Yeah, it's actually good for you at the long run. Like you don't worry about like whether or not your exam is okay or not okay. Like these are all very important questions. It seems like the for the last few questions, these questions are a little bit more technical. So, let's see this. Filled to the brim with water has 60 grams. Filled up to the brim with unknown liquid, the mass is now 380. Given the mass of the empty beaker is 20, and the density of water is 1 per cm cube. What's the density of the unknown liquid, right? Okay. So you gotta I mean, this more like a math question. It's not really physics. It's I mean, you think math, right? You think math. This is those kind of like word problems that you might get sometimes. Yeah. So your I mean, they said beaker, right, is 20 grams, right? Empty beaker is 20 grams, but then when you fill it up with water, it's 60 grams. So what's the mass of water? Yeah. So the mass of H2O is equal to 40 grams. So what's the volume of water then? Hmm? Sure. I mean, density equals mass over volume. So volume is mass over density. Yeah. So what's the volume? 40 what? 40 cm cube. Yeah. 40 cm cube. Right. So that'll be the volume. Okay. 40 cm cube. So the thing is that when you fill it with an unknown liquid Y, and you know and the total mass became 380, right? So what is the mass of liquid Y then? How much? No, no, 380 minus 20, dude. Like the beaker is 20, right? Why you minus 60? 60 is when you fill it up with water, right? Then 380 is when you fill it up with the other liquid, right? You don't did you think it was a adding on? No, but if you fill to the brim, you can't add on anymore, right? Yeah. So unfortunately, you have to infer. You have to infer that it was a separate thing, like it was another thing altogether. Yeah. So the mass of liquid Y used was what 360 grams. Am I right? Yeah, 360 grams. And then you're supposed to find the density of liquid Y, right? Which is going to be 360 grams divided by 40, because the volume of water will be the same as the volume of the liquid Y, right? It's the same beaker. So at first you fill it up full of water, right? So that's why we're trying to find out what's the volume of water used, right? But liquid volume is fixed. So if you pour out the water and you fill it with liquid Y, right? And you fill it up with liquid Y, it's still gonna it's still gonna be 40 cm cube. That don't change. Hmm. And then the mass of the liquid Y is like 360, right? Then divided by 40. Yeah, you get that now? Okay, so next question is it? Okay. You seem to have a common problem for density though. Mm. But I guess if it's like a common problem, I guess it's always solvable, right? It's always good. The I mean the worrying thing is that when you have general problems all over, then that's really hard. Um, so you did try to do same liquid, same level, same pressure, I believe. Okay. Um, did you try to ask me about atmospheric pressure? Yeah. So the answer is no. You don't have to account for atmospheric pressure because atmospheric pressure is acting on both sides, right? So they kind of like they cancel out. But it's not always like that because sometimes you could link the manometer into a gas chamber and the gas chamber is shielded away um from the atmospheric pressure. I mean, if it turns out like this, for example, right? If it's a gas chamber like that, then nah, right? I mean, then you have to consider the then you have to consider it separately. That means you have to consider this, right? Oops. Then you have to consider atmospheric pressure here and the gas pressure here different, right? Yeah. So what? Yeah, I mean they cancel out lah. I mean, like if you really want to like do show the entire working, it will basically be the atmospheric pressure here plus the water pressure here is equals to the atmospheric pressure there plus the water pressure here. I mean, when you write it out, then you can take away the pressure, ATM atmospheric pressure from both sides, right? So right here, right now, that means all you have to care about is basically the um the H rho G of the water, right? The liquid pressure from this 9 cm of water is equals to the the pressure by 6 cm of liquid X. Yeah. And they ask you for the density of liquid X. Yeah. Okay. So that's pretty much it. This one? Okay. Um, you have to be very careful with detail. So if you notice this, I mean at first glance you'll be looking at it and thinking like, hey, they're the same level, right? But then you'll be wrong because you cannot, sorry, you cannot just like ignore the fact that your basics must be strong. That means every time I ask you to compare, I give you a barometer, ask you to find out what's the air pressure, right? Your basics must be so strong that you're instinctively going to help tell me that I need to find this distance to the level of the basin. Correct? Okay. Then you need to compare to the level of the basin on the second day. Look at that, right? Like which one has the longer column? Day one or day two? So that means the atmospheric pressure on day one is higher. Oh, but they don't say, huh? They never said it, right? Yeah, they never said it. So A and like A and B are out, right? So we have to see the pressure point is less pressure than point Y, right? Um, or D, the pressure point at X, right, has the same pressure at Y. So this is a bit unfair. So obviously the atmospheric pressure is different, right? Okay, so on both days atmospheric pressure is different. But C and D has nothing to do with that. Like C and D, right, has nothing to do with like comparing the atmospheric pressure. They're just asking you to compare whatever's above X and whatever is above Y, like that and like that. Do you notice that they're the same height? They're the same height, right? So D is the answer. So always remember that pressure is caused by whatever's above, right? So if you look at X and Y, do they have the same amount of mercury above them? They have, right? They have the same height. I mean, we absolutely do not care that this is thicker, right? Because yeah, we don't. As in like I'm just assuming that we already went through enough questions to understand that the thickness of the tube does not affect like how much pressure we read, right? So I'm not even gonna bother addressing like oh, this is thinner, that one's thicker. There's no point in that. But what's more important is I think is more concerning about is whether or not you get mixed up regarding the atmospheric pressure versus like option D, right? So this question is very tricky, right? This question is very tricky because it kind of like plays with the lengths, right? So let me try again, right? So anyway, the answer is D, right? Because point X and point Y simply has the same amount of height of mercury above that very point, right? I mean, you look at the diagram shows you the same height, right? Same height means same pressure. Yeah, so then if you ask me about the atmospheric pressure, that means the outside pressure, then if I want to go and like observe the atmospheric pressure, then I literally will have to compare from this height of the column here, from this height of the column here to the height of the basin level here. Do you see that basin level here? Like right here, the basin level. Like I need to find out what's that height there, right? That this one is atmospheric pressure, okay? And then from this side here to this side here, this height here, okay? And that one is the day two atmospheric pressure, right? That one, day two atmospheric pressure. Day one, it looks obviously more than day two, right? Yeah, but there's no option for that. So we can't put any of the like, A or B. Then now we have to check whether C or D is correct. If they give you an option saying that atmospheric pressure on day one is larger than the atmospheric pressure on day two, yeah, sure, that's correct. But they didn't give us an option, so we just have to figure out what else to choose, right? Because A and B throw away already, cannot already. So we have to choose C and D. And then when you look at C and D, they're asking me to compare something else. Right? I'm comparing something else. I have to move on. I can't think about atmospheric pressure anymore. Because C and D are not asking about atmospheric. They just simply asking you, what's the pressure at the bottom here? Right at the bottom here, like this. Then the pressure of both of them will be the same. Because they have the same amount of mercury on top. Okay? Yeah. This one here? Okay. So the shaded one is water. Sorry, the lines one, the one with the shaded lines, okay? is water, while mercury is the dark gray one. Correct? Yes, you're right. Water is less dense, right? Water is less dense. Okay. How about this? Same level, same liquid, same level, same pressure. So mark out these 2 points here. Do you see that these 2 points are the same pressure? Okay, mark out these 2 points here. Do you see that those 2 points are same pressure? Now, I'm not saying that A and D are correct. I'm just marking out. If I want to analyze using same liquid, same level, same pressure, I need to mark out the points where they are supposed to have the same pressure, right? Supposed to have the same pressure. So I'm just marking out them out. And now I'm going to check whether or not they're correct. All right. So let's see whether A is correct, or let's try to understand why A is not correct. Okay. So what's going on at A? What's happening on the left hand side here? Like what's above this cross here? Water and what? So atmospheric pressure and water, right? Okay. So do you see that there's this amount of water here like that? Okay. Then let's look at the same pressure on the other side, over here. All right. Do you see that there's this amount of mercury here like that? Yeah. So can you see that, oh, like option A kind of like shows me that I have a longer column of mercury that will balance a shorter column of water. So then you ask yourself, do you think can that happen? No, right? But why not? Yeah, the other way around, right? It should be the other way around, right? I mean, we can tell that D's the answer. We can tell D's the answer. But how about B? Why is B not the answer? Yep, that's right. Correct. So does it mean that water has no pressure at all? No, right? So B is not possible because, like, what we are showing you here is that what they're showing you here is like, oh, B the water doesn't even push this liquid up at all. Like there's no, yeah, you know. So no. So C is the same as A, right? Again, C is trying to indicate that, oh, mercury is less dense than water, which is not true. So D's answer, because for the amount, right, of water, it will, like, you just need a shorter column of mercury to have the same amount of pressure. Yeah, you understand this? Okay. Then, but the thing is, the thing is, okay, knowing that density of water is what? 1000 kg per meter cube. Okay, and density of mercury is 13,000 kg per meter cube. Okay, now based on that, right, I kind of want to ask you, if say for example, right, the this height here is 10 cm, for example, right, the height there is 10 cm. That means I have 10 cm of mercury. Like, what's the equivalent height of water that you need to balance the 10 cm of mercury? 13.6 times. 13.6, because this is 1000, this is 13,600, so it's 13.3, but 13.6 times. So the height here should be 10 times 13.6 cm. It should be 136 cm. So D, the scale is not drawn right. Yeah, it should be 13.6 times more. But okay lah, right? I mean, D is a bit not quite right. Okay, there you go. Insomnia? Oh. You see, right? It's awesome, that you're like, that we have this, um like, a trend of questions. Okay, But I sort of like, I'm a little peeved, okay? Sorry, Yi Guang, I'm a little peeved that I mean, even though your working looks correct and all that, but you're not following the pattern that, the kind of like the procedure that I always prescribe. Same liquid, same level, same pressure, right? So it's kind of like, like then why do I keep talking about that? Like, why do I keep saying that? Because that's the procedure that would guide you into understanding the question. So that means that this what we're showing here is that this pressure here is the same as that pressure over there, right? Then you gotta ask yourself, so what's on top of those points, right? So what's on the left hand side? Then what's on the right hand side? Uh-huh. Correct. See? So I mean, you see, right? That this working here is correct, right? The pressure of the gas is equals to the atmospheric pressure plus the H rho g. But like I guess my point is like, why didn't we or you get into that mode, right? Hang on, sorry. Hmm. My video blur now. Okay. So yeah, and you now realize that why is it that every time, like as I'm going through all these questions with you, like I almost use this same liquid, same level, same pressure. I keep using it, like like why? There must be a reason why. So you gotta see the pattern, right? You gotta see that, oh, like that's the way I solve it. Does it mean that you have to come up with a way to solve it yourself? No, you just take the way I'm teaching you to solve it. So same liquid, same level, same pressure, right? Use the same procedure. But I think that's what you're lacking. I guess that's what's causing all these problems, which is great because, like, when you have a common problem, it can be fixed when it's fixed. Fuyo, what's this? Okay, C is the answer lah. Yeah, but why? Hmm? C is the answer. Okay, so the keyword is, right, all by radiation, right? So now the question is, right? I mean, when I was looking at this, trying to find out the answer, right? I didn't even bother looking at like all these like numbers or anything like that. I just went to look at this: in air, in space, in water. In space, C. I mean, what's the other kind of, like, what are the three types of thermal transfer you have? Mm-hmm. Mm-hmm. So why is it that, you know so you see they say by radiation, right? So I must be thinking, oh, by radiation. That means I cannot allow any conduction at all. I cannot allow any convection at all, right? So, you know, I got to make sure that I'm in a place where there is no conduction. The only way that you can like completely eliminate conduction and convection, right, is to make sure there's a vacuum around it. So when this shiny metal satellite is in space, that means it's out there in outer space where there's no air. No air means no convection currents, right? Air is a poor conductor of heat, correct? But if air is a poor conductor of heat, but if there's no air, it means air was removed, then there's absolutely no conduction at all, right? Because the objective is I want to lose all by radiation, like not even a single bit. like if you were to compare to air, right? Not even a single bit to like to air. Where we say that it's air is a poor conductor of heat. Poor conductor of heat means that there's still some conduction. Okay. What I can understand is why some students get this wrong because they see shiny metal, right? Then they might be thinking, oh, shiny metals are not a good radiation, like no, not good for radiation, right? Yeah, you're not wrong. It is true. But if you have a satellite in space and there's no air, there's no nothing around it, the only way it can lose heat is by radiation, even if it's a poor radiator of heat. Yeah. So C is still the best answer. Okay? And right. So there we go. Okay. Hey, how come all these questions only coming now? Like, shouldn't these questions be coming before the before the exam? Huh? When's the exam? Finish already, right? Huh? What the hell? How come you didn't tell me? How am I supposed? Wait. You mean the other year threes also? Ah, shit lah. Ayo. How come nobody tell me anything on Ayo. Ah, should be right. Yeah lah, yeah. Nathan already messaged me. Okay. Never mind. At most, I send them the recording of this one later to them. But anyway, like already, so they don't do like anyway. What you want here? What's going on here? Bruh, this is math problems lah, bruh. Like guarantee is math problems. 100% guarantee. You go and draw a normal here. Right or not? Yeah. If you draw a normal is 90 degrees, right? So what's the angle of incidence? Then you answer. brother. You see, you know what's okay. I'm gonna let you think about this. What do you think was the problem that was stopping you from answering this question? No, no, no. That's not the problem. You know what's the problem? You never draw the normal. The first thing is to draw the normal, right? Like reflection, right? Okay. I mean, yes, this is reflection. Reflection first thing is go and draw the normal. If you get actually, I got one question from just now from the who ah. Oh no no, but she's older than you. Phoenix. There's this girl called Phoenix. Hang on ah. Oh, why she send me so many? Oh no no no, I already went through it. Wait ah, there was this question. Yeah, this one. Like I forward to you lah. So wait ah, I send you all the light questions because she's having all troubles with the light questions. I forward to you. Anyway, okay, all right. I'll go through those questions in a while later. But my point is, any light question, draw normal first. Then you go and find the angle to the normal. Like that's the standard. Okay. Then after that, if it's a reflection question and they ask you to find whether or not the eye can see or where's the image, then you need to reflect the image. Then after that, if let's say they ask you to find the size of the image and all that, then you use the similar triangle method. So you see, huh? You know the painter in the room, you watch the video, you didn't. You didn't watch my light lessons. Ah. Wait, you see, right? Now my concern is like, I mean, I left you to go and, you know, watch the light videos. I'm just like wondering whether or not like were notes taken lah, in that sense. You took notes, then you understand when I say things like painter, like yeah, it was this one. It was this one here. This one, right? They ask you to find the size of the image. And then what was the method that we used here? This was similar triangles, yeah. So the reason why I structured the lessons, these lessons are not random. These lessons form the basis of how you solve all of them, like all the questions at various points um in the practices. So always remember, draw the normal. If it's a reflection, find the image. And if they ask you to find size, use similar triangles, right? Which is actually the list of questions I sent here as well, right? This one here, right? For example, this one. They ask you, where's the position of the image, right? So is it A, B, C, or D? Okay, right? Yeah, I don't know, like whether you know where it is, but like if you had to work it out, like how would you find the image? So anyway, this one's 40. You understand already, right? Okay. I mean, what if it was like this question here, like that? Like, how would you find the answer for this one? Where? So you have to draw it perpendicularly across first, right? So this is the first image, right? Sorry, small letter I. This is like I1, okay? And then what you need to do is you need to extend the second mirror, and then you flip it again, right? But this time around it is perpendicularly to this mirror here like that. So the answer is C, right? But all of this, whatever the situation of the question is, they are all based on you know whatever basics I've gone through. Like I tell you, if it's reflection, it has to be done. Like you need to consider this step, this step, this step, this step, this step. It's not random. There are certain procedures to doing this. Like, I mean, if you think about this, um, it's kind of like how you go about your daily things. Like you wake up in the morning, you take a piss, you go and brush your teeth, right? And then you sit down for breakfast, and then you dress up and you go to school or something like that, or maybe in some of that order. So whenever we solve physics questions, it's pretty much the same. There's a certain, like, there are a few steps to follow, right? And that makes our lives a lot easier when we're trying to solve physics question, because we don't have to go and consider like, oh, if it's this, then maybe it's that. If it's that, then maybe it's this. You know, there's no exceptions to it, so it's always done in this manner, right? It's just like the same liquid, same level, same pressure kind of questions, you know? Yeah. Okay. So, and then for example, this one here, they ask you how high is the wall. You can use similar triangles. I leave that to you if you want to. Then there's this question here, which is like asking you to like find out which one shows you the correct path. Then what you're supposed to do to check, right? Hang on. Then there was a lens question as well, right? And then yeah, so all these things, like all these things, I mean, they're all here for you, so you can go and try it out if you want. Okay, all right. So I would strongly suggest you try it out. Hang on, let me just take a look. I thought I remember seeing one other question. Oh no, don't have. Yeah. Okay. But yeah, go and try it out. Okay. Like go and do more. Yeah. Yeah. Back to your questions. Hang on. This one here. Okay. Yeah. Oh, so this is a so it travels east at a constant velocity. At time zero, the velocity starts to change and the acceleration is constant, negative 4 meters per second squared. The car maintains an acceleration for a period of 10 seconds. How is the car moving at t equals to 6 seconds, right? Okay, what does this mean in English? Let's try to make sense of it. I don't want to show you equations. I want you to make sense of it. No, the acceleration doesn't tell you that it's traveling. You see, right? Your car, right? Your car is traveling eastwards, right? At 20 meters per second first, right? Then what does this acceleration mean? Yeah. So there's a decrease of 4 meters per second, right? Loses 4 meters per second. Good, right? So how long would it take to stop? 5 seconds. Good, right? 5 seconds and it'll stop. Am I right? 5 seconds. But then they say it maintains the acceleration for 10 seconds. So after the fifth second, what happens? Now it does, but you have to let it slow down first. It needs, if you want it to change direction, it needs to stop first, then it can reverse. Yeah. So in the next 5 seconds, right, it will continue to move. It will now move backwards, and therefore at the end of the 10 seconds, like, where is it headed to, and how much, and how much will the speed? Ignore the option. How much is the speed now? Good, 20 meters per second, right? Right. You know that it's been going backwards, right? Okay. But then they didn't give us. They didn't tell us, like, oh, it's traveling west with a speed of 20 meters per second, right? So what should we choose? Either C or D. What should we choose? What that? D, right? Increase. I mean, it says that it continues with this acceleration, right? Actually, it's not a very fair question because it didn't tell me that, oh, it continues this acceleration for a period of 10 seconds and beyond, right? Oh, no, no, sorry. Oh, sorry, I'm so sorry. They asked here at t equals to 6 seconds. When is 6 seconds? That means five, right? Five here, correct or not? Five here, and then when it travel backwards, 1 second, right? Isn't that what the question is asking? At the 6 second mark, right? So now my question to you is this: at this on the 6 second mark, at the 6 seconds, right? Okay, on the 6 second mark, right? Let's not confuse you, right? At the 6 second mark, what's the speed now? At that point, what? Good, 4 meters per second. Excellent, right? It's 4 meters per second. But then from six all the way to the 10 second mark here, right? All the way to here. Yeah, I mean it's just increasing in speed lah, right? All the way until 20 lah, right? Okay, so I mean D is the answer anyway. So yeah, traveling west with increasing velocity. What? You can, you can, you can. But that's, like I say again, that's just you plugging in the equation without understanding and visualizing the scenario. So v equals u plus at. I'll tell you this, it's just an equation. Like it's very, it's a shortcut equation. But if you don't understand what's happening, then there's no point just plugging in the equation. I can just show you, I mean, it's like, aya, oh, kuang, it's just equation, right? V equals u plus at. Your v is 20, then you plus minus 4 times t is 6 seconds, right? So what's the answer here? Then the answer is minus 4, lor, right? But without showing you the whole journey, right? I mean, just take the answer as minus 4 lah. Then can already lah. Then let's just move on. Yeah, but then that's not gonna help you next time. Okay, next one. This one, heat capacity. Okay. Um, this one has a lot of concepts inbuilt into this question here. There's a lot of concepts here. Let's ignore the question, okay? Let's just ignore the options. Let's not care about the options first. Let's understand many things first. Number one, are all of them um are, are all of them boiling? I mean, eventually they all boil, right? Like every one of these like slopes up is when it's a liquid, right? So this is like liquid Z, and then there was liquid X, and then liquid Y, right? But eventually all of them reach boiling point, their respective boiling point. So Z reached boiling point, Y reached boiling point, X reached boiling point, correct? Okay, right. So we understand that one first. right? Then do we understand that they all, like, I mean, the graph gets cut off at the same point. So therefore, the graphs for all of them have the same time. Hello? Okay. Do we understand that the heating at the same rate? Heating at the same rate, right? Do you understand that that means that all three substances have been provided with the same amount of energy? You understand that, right? Okay. Do you understand that um their the increase of their internal energy is all the same? Why? Very good. Yeah, it is, right? Increase of internal energy is the same for all, right? For all, okay. Because it is the sum of all the K and P. These all red ones, these red ones are all KE, correct? And these pink ones are all, oh, there's no difference in the colors. These yellow ones, they're all PEs, correct? So even though some have a different increase in KE, some have a different increase in PE, actually, how do we know that they have all the same internal energy increase? No, yeah, absolutely right. So the amount of heat being supplied, same rate, right? And same amount of time. So no matter how much KE one is gaining and how much PE the other one is gaining, in the same amount of time and in the same heating rate, they all gain the same amount of internal energy. Right? That's good. Okay, that's good. Right? So at least we know that. All right. Okay. Then we can continue to compare other things now. So now I want to compare about the slope, right? I want you to compare the slopes here. So for Z, right? This one here, you see this slope here? Now Z is the steepest, isn't it? What is the state of Z? This red line here. Okay, how about Y then? What's the state there? Liquid also, right? So let's say I compare liquid Z and liquid Y. I want you to compare liquid Z and liquid Y. Okay? Right, liquid Y, right? Um, I want you to tell me in the same amount of time, which one rises by temperature more? Liquid Z, right? Rises faster, like in the same amount of time of heating, right? Then can we conclude that liquid Z has a smaller specific heat capacity? Can we confirm that? Why? Has what? Yeah, exactly. So smaller specific heat capacity means that you you supply less heat, the temperature jumps more, right? Okay. I mean, honestly, I mean that's the answer. Like Z has the smallest specific capacity, right? Right? Because it has the steepest graph. But you know what? To be very, very fair, actually they should have said liquid Z has the smallest specific capacity. I mean, I don't know about the other states. I don't know about the gas. I don't know about the solid, right? So, I mean, if you want me to be very explicit, I should say liquid Z has the smallest specific capacity. You get it? Yeah, okay, good. Then, then the next thing is, but how about latent heat? Let's say, how about like I want to compare latent heat or vaporization. So if I want to compare latent heat or vaporization, where should I look at? Right, the flat parts, right? Okay, the flat parts, okay. Do you know what I'm gonna? Okay, so the thing is, right? The thing about the flat parts is Actually, right, we don't know when it stopped boiling. We just stopped here. We just stopped the experiment there. Has X, Y, and Z boiled finished yet? So there is no way for me to compare their specific latent heats or vaporization. Like there's no way. Like like what if like X, right, becomes a gas after this, right? And then or maybe Y continues to boil for super long, right? And then or maybe Z continues to boil and then go like that. Like how, I don't know. We don't know what's the how far like knowing that it started boiling first doesn't mean that it's going to be boiling the longest, right? Why might boil the longest, right? We don't know. We actually have no idea. So there's no way to tell. So we can't conclude anything about the latent heat of vaporization. So A and C are like out. There's not enough information unless you finish a graph until they become a gas, right? So we can't compare. Yeah, we can't compare the latent heat of vaporization. Okay, this one. Oh, this one is an old school question. Yeah, you should try to understand this one. This is work energy power. Okay, this work energy power here, right? So you want me to like we have to calculate right the power, right, generated by the forward force, right? So you got to remember that you did write it down, work done over time, but I think you forgot that we are supposed to manipulate this force and distance over time, right? Then force and distance over time, then force times velocity. So basically you have to take force times the velocity to give you a power, but you need to convert the 60 km per hour into meters per second. So you need to figure that one out. How do you convert 60 km per hour to meters per second? There you go. You know this. Yeah. So then the thing is that you're missing this part lah. You're missing this thing here. This relationship. Yeah. Okay. Right. So that one this one is just plug equation and play. This one don't need to think so much one. They want to find power of an engine, you take the force divided by no the force times the velocity. Okay. Oi, what is this? Why? Okay. This one is what? Image is from where? Sorry, object is from where? It is object infinity, right? Yeah, object infinity. Object at infinity, right? Where will the will image be? Uh, no. That's why I see ah I send you all the videos you all tell me you all got watch, but then how you all got to learn how to use this seriously. Right here lah, right here. It's right here in front now. When your image your object is at infinity, object infinity, right? When the light rays come in, right, image will be at F. Yeah, you have to memorize it, right? I mean, I can show you how to draw it. Like, I don't know whether you remember, like, these are random light rays, right? These are random light. Cause it's very obvious that I don't know, you did not catch the details, eh? Don't know, like it feels like you just I don't know, like it felt like it feels like you felt it was a chore to watch this thing. Yeah, you gotta try to remember it. It's like I even illustrated this a little bit more in detail, you know, like this is what I was doing for the MGS girls and all that. Right? So try to just skim through it again, okay? Right? Because I mean I gotta go because I still got another lesson going on, right? And I can't run through the whole light lesson with you again. It's just yeah, It's on video. Go and watch it, okay? So the image will be at infinity, the image will definitely be here. Sorry, the object at infinity, image will be at f, okay? And since f is a focal length, right, the image will be here, right here on the focal plane like that. Yeah, yeah, without, I mean, if you really had to draw it, if you really had to draw it, you would realize that none of the light rays they gave you, right? None of the light rays they gave you are, you know, uh, the correct light rays that we have to use. So what I'm going to do is I'm just going to draw one light ray that passes through F. Right? Do you see that? The blue one. And then I know that after it passes through F, it will become a horizontal line like this. Okay, do you see that? All right. Then I should have another light ray that passes through the center, undeflected, right? Yeah. So once I extend it, you see where they cross? Where do they cross? Wait, they cross at the focal plane. All right. Oh gosh. Right. Hang on. Like, oh no, sorry, my pen ran off. Okay. Like the the image will be just right here. You see where the two lines cross here? Yeah. The image head will be there. Like right here, like this. Right, the image head will be here. I'm gonna just choose red color for you to see. Down here. That's where the image will be. You understand this? Yeah. So hey, you better go and review all the light stuff. Do a quick run through because compared to the others, right? You are the one that has the most topics, like because you have this whole light and lenses, you have this huge ass topic that is gonna eat up a lot of your MCQ scores. Yeah. I mean, how was paper two anyway? But oh, okay, cross fingers, right? But MCQ will be harder, I guarantee you. So yeah, sure, for sure one. Like like for sec three, right? Usually teachers will try to jump scare the student, like boo, that kind of thing, right? um Maybe for IP they go lax on them. I don't know. My sec 4 IP students, they all tell me that the exam was very easy this year. um but I don't trust but I know the O level was hard. The O level prelims was hard. The sec 4 O level prelims, the Harry Curran, they all, yeah, yeah, the exams I saw, it was hard. So I wouldn't be surprised if they make it a bit harder for you, right? I mean, hard, when I say hard, is this kind of, yeah, like that lah, where a little bit trickier. You have to use memory work to understand this. Yeah. So go and quickly catch the video, okay? Okay, can send it to me. Right, the rest is my questions, right? Yeah, like, right. Yeah, you go and try this out. Yeah, and I will send you the recording for this one because this student asked me to go through these questions. I went through. Yeah. Well, did you send me already? Yeah, send you this one. This one. Wow, what the heck is that, man? Doesn't look too familiar to me. What was this? Wow. Okay. That's not a fair question. Oh, dude. Oh no, yeah, it's a curve. It's a curve. It's a curve. Yeah, it's a curve. It's a curve. Uh This is not a fair question at all, dude. What the heck? Which year is this? 2020. Oh shit, I remember this. Huh? 2023? Yeah, I remember this. This is not a fair question at all. Dude, is this from the IP paper? Express ah? Crazy man. The answer is D, right? Huh? I think the answer is D. But why? Yeah, lor. Yeah. No, but you see, right? Actually, right, it's a very unfair question because like how are you supposed to know that D is the answer? Because I mean the gradient here is steeper, you know what I mean? Right? And the gradient here is less steep, what? I mean even C is also correct, what? You get what I'm saying? Yeah, huh? As in it's like you're asking me to compare between 90 degrees Celsius water versus 50 degrees Celsius water in the room, right? How do I know which one will cool down faster to room temperature, right? And I would think that 90 degrees Celsius water, I mean, it's hotter, right? Generally, hotter objects will take longer to reach room temperature, lah, right? Yeah. So that's the thing I cannot understand. Like why would they? I think it should not happen again. Like if to me, right, if you choose either C or D and your teacher mark you wrong, at least I know that you chose either C or D based on your understanding that hotter means you know, there's a greater rate of radiation, which is what I'll be quite happy about lah, because you will remember that lah. Yeah. Okay, can. Okay, look, I gotta jump. You just let me know if you got any questions because I'm still gonna be having a lesson. So if I can, I'll just reply you as fast as can. Okay.